Is Dr. V. Tanigaslam, reader in chemistry, chemistry wing. Dear friends, today we are going to discuss about the following headings. One is a trans effect, second one is the order of the trans effect, third one is the explanation of the trans effect with the suitable examples, fourth one is the trans effect in synthesis, fifth one is the application of the trans effect, sixth one is the reaction mechanism of the trans effect. Let us see one by one. See, dear friends, we know the square planar complex. Square planar complex means one of the best example, tetracyanoplatinum or tetracyanonickelate. Another complex, tetrachloroplatinum 2. So these are the best example for the square planar complex. So what type of the hybridization involved in the square planar complex? D, S, P2 hybridization. One D orbital and one S orbital, and two P orbitals are involved in the complexation. See, the trans effect exists in the square planar complex. So what is meant by trans effect? We know the labilization of the trans ligand, trans to trans direct ligand. It is known as the trans effect. So how do you explain, the order of the ligand in the trans director? We are conducting the same complex with a different substituent in the complex and measure the rate of the hydrolysis. Based on the rate constant, we are classified the following order. One is among these, the cyanidine has the more trans director than that of the other ligands. The cyanidine, carbon monoxide, hydridion, methyl cyanide, and so on. Finally, the water is the end of the series. It shows that if this type of the ligand, like the cyanidine, act as a trans director, the replacement of the chlorodion from the reaction is very fast when compared with the other type of the ligand act as a trans director. So from this we can arrange the following order. Next, explain the trans director. How do you measure the trans effect? The trans effect measured with the two suitable examples. One is tetrachloroplatinum 2, other one is a tetramine platinum 2. These two are two best examples to explain the trans effect operated in the square planar complex. First, you take a tetrachloroplatinum to react with ammonia to form the mono substituted trichloropplatinum 2 complex. See, again we add one molecule of the ammonia in the reaction medium. The question will be arise. So which chlorodion undergo replace? We know among these two, the chlorodion has the more trans director than that of the ammonia. So ammonia, the metal nitrogen bond is less labile. And also the ammonia has the least trans director. So ruled out, the replacement of the chlorodion by ammonia is very less when the chlorodion opposed to ammonia. So what do you do? Again we think about the chlorodion trans to chlorodion. So the chlorodion trans to chlorodion is more labile. So the replacement of the chlorodion by ammonia is more easily when compared with the replacement of the chlorodion trans to ammonia. So we get the cis product alone because of the trans effect is operated in the reaction medium. What about the trans product? Trans product is not found in the reaction medium. Next, you take another example, one of the best example, the tetramine platinum 2, react with the chlorodion. First step, monosubstrate or generally called the monochlorosubstrate triamine platinum 2 complex is formed. Next again we add one molecule of the chlorodion to the reaction medium. What happened? We know the labilization factor or the trans directing factor. Here we are taking the trans. See, the trans director, chlorodion has the more trans director than that of the ammonia. So the replacement of the ammonia by chlorodion is more possible, the chlorodion trans to ammonia, than that of the ammonia trans to ammonia. And also the metal nitrogen, the platinum and the nitrogen bond is less labile. The replacement of the ammonia trans to ammonia is very less. So we get only the trans product in the reaction medium. Next we are going to see about the trans effect in the synthesis. We are prepared the various type of the complex by using the same starting material and different reagents. First we are prepared the complex 1. You start with the tetrachloroplatinum 2. The tetrachloroplatinum 2 is react with ammonia. So one of the chlorodion is replaced by the ammonia to form the monosubstituted trichloroplatinum 1. It is intermediate. Again we add one molecule of the pyridine. So the question will be raised. So which chlorodion undergo replaced by ammonia? Either in the ammonia trans to chlorodion or chlorodion trans to chlorodion. We know the trans director series, the chlorodion has more trans director than that of the ammonia. One of the chlorodion is replaced by the incoming pyridine. So the best chance, the chlorodion trans to chlorodion is more possible than that of the chlorodion trans to ammonia. So we are getting the one of the product, the ammonia pyridinium dichloroplatinium 2. So this complex again we treated with the promadion. We know the promadion is a best trans director among these three. Among these three means promadion, chlorodion, ammonia. So which is undergo replaced? Either the amine chlorodion or the pyridinium chlorodion. When you compare with the pyridine and ammonia, pyridine has more trans director than that of the ammonia. So pyridine is easily replaced by the chlorodion. Pyridine, because of the trans effect is operated. So the labilization of the metal chlorodion is more compared with the chlorodion trans to ammonia. So by addition of the promadion, chlorodion trans to pyridine easily replaced by the incoming promadion to form to form the final deciding product of the complex, square planar complex. Another reaction we have carried out. The starting material is tetrachloroplatinum 2. See, the tetrachloroplatinum 2 is react with the pyridine to form the monosubstituted trichloro complexes. So again we add the ammonia to the reaction medium. What happened? The question will be raised. So which has the more trans director? What is the role of we know the ammonia is a weak trans director compared with the other ligand. Due to the labilization, the chlorodion trans to chlorodion is easily replaced by the addition of the ammonia to form the ammonia substituted intermediate complex. Again this complex is treated with the promadion. The promadion is a deciding factor or determine the final shape of the complex. So which chlorodion undergo replaced? Either the pyridinium trans to chlorodion or the ammonia trans to chlorodion? We know when the trans director, pyridine has the more trans director than that of the ammonia. So, the replacement of the chlorodion trans to pyridine is more possible. So, we get the new product. Another geometry isomers of the scorpionite complex. Third one, we are start with the 2 moles of the ammonia. 2 moles of the ammonia is react with 1 moles of the tetrachloroplatinum 2 complex. So, this complex we already saw this product is a predominant due to the trans effect. Again we add 1 moles of the pyridinium to the reaction medium. What happened? Which undergo replaced? Either the ammonia or the chlorodion. We know the chlorodion has the more trans director than that of the ammonia. But due to the labilization and the bonding character, the platinum and the nitrogen has less labilized than that of the platinum chlorodion. So, the chlorodion easily replaced by the incoming the pyridinium instead of the replacement of the ammonia by pyridine molecule. So, the chlorodion easily replaced by the pyridine to get the intermediate product. Again, 1 molecule chlorodion added to the reaction medium. So, we know bromadion is more powerful reagents, more trans director than that of the other type of the ligand present in the complex. So, the question will be raised. So, which is undergo replaced? Which ammonia molecule undergo replaced? Either in the pyridine opposite to ammonia or chlorodion opposite to ammonia. So, due to the trans director is a main role to determine the final geometry of the complex. We know among these 3 ligands, the chlorodion has more powerful trans director than that of the other type of the ligand. So, the chlorodion, the ammonia trans to chlorodion easily undergo replaced by bromadion instead of the pyridine opposite to ammonia. So, finally, we get 3 different type of the isomer is attained from the same starting material and different experimental conditions. So, this technique is very useful to prepare the various substituted scorpionar complex in day-to-day applications. Dear friends, next we are going to see another methods, the application of the trans effect. See, we know how do you distinguish the cis and trans isomers. In organic chemistry, there are the different techniques are available to distinguish the cis and trans isomers, namely the dipole moment of the compound. Second, some chemical reactions. Third one is the melting point. Melting point is one of the important factor to determine the configuration of the compound. But in the case of the scorpionar complex, one of the best test to distinguish the cis and trans isomers. The test is known as the Kurnokoff test. You take the 2 types of the complex, one is cis and trans. One of the best example diamine dichloro cis, diamine dichloropplatinum 2, another complex trans diamine dichloropplatinum 2. So, these 2 we want to check whether is cis and whether is a trans. By additional let us see one by one. You select the cis complex is treated with the thiourea. One of the chlorodion is replaced by the thiourea. Why the chlorodion is replaced by thiourea? We know the platinum nitrogen bond is less labile, or in other words, the strong bond is exist between the the platinum and the ammonia. So the replacement of the ammonia is very difficult when compared with the chloride in the complex. So thiourea easily replaced the chloride present in the complex. So we get the monosubstituted, the thiourea intermediate complex is formed. Again we add one molecule of the thiourea in the reaction medium. See, the trans effect is operated here. So which ligand is replaced by the thiourea? Either in the chloride opposite to ammonia or thiourea opposite to ammonia. The question will be raised. We know according to the trans-directing series, the chloride, the thiourea has the more trans-director than that of the other type of the ligand present in this the complex. So the thiourea influence or weakening of the bond trans to the opposite to the metal and the nitrogen. So the replacement of the ammonia is more easy when compared with the chloride trans to ammonia or ammonia trans to chloride. So we get the disubstituted thiourea intermediate complex. Again we add one molecule of the thiourea in the reaction medium. See friends, we know the one of the labilization. Labilization means the weakening of the bond between the chloride and metal, the platinum is more than compared with the platinum and the ammonia. So by addition of the thiourea, the chloride is easily replaced. The chloride easily replaced by thiourea instead of the ammonia. So in the third step, the chloride is easily replaced by the thiourea. Next, again we add one molecule of the thiourea in the reaction medium. So we know the thiourea has the more trans-director than that of the ammonia. So the replacement of the ammonia trans to thiourea is more easy. Finally we get the tetrathiourea platinum 2 complex. Whereas when I select the trans diamine dichloroplatinum 2 complex, it is treated with the thiourea. We know the labilization of the chloride trans to chloride is more easy. So the replacement also very easy by the thiourea. We get the trans product, but the replacement of the ammonia by thiourea is very less because of the first factor, least labilization, and another factor, strong bonding between the ammonia and metal, platinum metal. So this test is very useful to identification of the cis trans isomer in this square planar complex. Another theory we are going to discuss about the mechanism of the trans effect. So the mechanism of the trans effect is explained by the two theories, namely polarization theory or the polarization theory of the Greenberg. Another theory, the bibond theory. See, these two theory is clearly explain the trans effect operated in this square planar complex. So what is meant by polarization? So in general, when increases the size of the atom or the molecule, the polarization is more possible. One of the best example, you take the iodide ion. We know the halogens. Halogens means the fluoride ion, chloride ion, bromide ion and iodide ion. So among these, which has the more polarizing power? The iodide ion has more polarizing power than that of the other type of the halogens, because of the size is more. The size is more means the more easily polarizing polarizability and polarizing factor is greater for iodide ion compared with the other type of the halogens. So before they going to discuss about the polarization theory, you select the one of the symmetrical complex. The best example, the tetrachloroplatinum 2. Tetrachloroplatinum 2. It is highly symmetrical. It is highly symmetrical complex. So the individual dipole moment is cancelled by each other. The resulting dipole moment of the complex is said to be 0. So there is no trans effect is operated in this complex. One of the chloride ion is replaced by the iodide ion, and you measure the polarizability and to measure the trans director. So the iodide ion, due to the polarization, the iodide ion alter the electron density around the central metal ion. So the polarizability is all either decreases or increases the electron density between the opposite bond. Bond means chloride ion. So due to the polarization, the weakening of the bond between the platinum and the chloride ion. So the replacement of the chloride ion is more easy by incoming ligand of the groups. The another factor also supported the polarization theory. What are these factors? The central metal ion also influence the polarization. See, we know the d electron system, the d electron metal ion like the 5d platinum, 4d palladium 2 and 3d nickel. So when compared with these three metal ion, platinum has the more polarization than that of the palladium and nickel. So among this, nickel has the less polarization than that of the platinum, the palladium and the platinum. So the central metal ion also influence the polarization factor. Another factor, the double bond of the trans direct ligand. See, we know one of the best example, the ethylene has the double bond. Due to the polarization, it is influenced the weakening of the bond between the opposite, weakening of the bond strength opposite to the ethylene molecules. How? Due to the polarization, the shifting of the pi electron from the one atom to another atom. So one is a positive, another one is a negative. So they enhance the polarizing power in the complex. So the rate of the substitution is greater when this type of the ligand present in this covalent complex. Another example, one of the best examples, cyanide ion, carbon monoxide. And the next day we are going to see another theory, bibond theory. This theory is very useful to to explain the trans effect is operated in this covalent complex. There are so many scientists are explain these theories. One of the scientist's name is Chant and Orgel. Chant and Orgel pointed out the activated complex improve the bibonding theory. Activated complex means it has the higher energy than that of the starting material. See, everybody knows. See, the activation energy is greater means the intermediate complex is more stable. Intermediate complex is more stable. The activation energy is least means the rate of the substitution very fast, very fast. It is everybody know. The same concept is operated in the trans theory, the square planar complex. The formation of the trigonal bipyramidal intermediate, the activated complex, and the proposed that the bibonding ligand would stabilize the intermediate. How the bibond? What happened? Suppose the trans director has a vacant orbital. Vacant orbital means it is ready to accept a lone pair of electron from the electron rich center of the central metal ion. electron rich center, the center of the central metal ion. So the metal ion ready to accept a lone pair of electron to the vacant orbital, either the d orbital or the p orbital of the ligand, and to form the bi bonds. So during the bond formation, what about the electron density opposite to the transdirector? The question will be raised. See, once the metal ion donate the lone pair of electron to the transdirector, the electron density is reduced between the leaving ligand, means it is replaced by the other entering group. So decrease the electron density and more positive charge is created. So this factor is influenced, the rate of substitution is accelerated in the square planar complex. See, another theory, during the formation, during the activated complex, or it is increase the coordination number about 1 unit to form the trigonal bipyramidal intermediate. In general, those ligand has the high electron negativity, it is preferentially lying the opposite. One is above the plane and another one is below the plane about the trigonal. Trigonal means the transdirector and the leaving ligand and the entering group. These three are formed trigonal pattern, and another these two always one is lying the above, another one is lying the below the plane. So the formation of the intermediate complex is very useful to synthesis of the square planar complex. See, when I start with the cis complex, means the formation of the product also the cis. The formation of the trans complex means the final product also trans. So this theory also explain the very useful to distinguish the cis and trans complexes. So now conclusion about the trans effect. The trans effect is a very useful to prepare the various substituted coordination complex. Another important applications, we are able to distinguish cis and trans isomers. Third one is after preparation of the different substituted complex, it is useful in the field of the bioinorganic field.